Hi everyone, in today's challenge we are going to solve this problem. The problem name is unique path 2 and the problem number is 63. Alright guys, so first of all what we are going to do? We are going to clearly understand the problem statement first of all. After understanding the problem statement, then we will move to the logic part, and in the logic part we are going to see how we can solve this problem. What is the logic we are going to use to solve this problem? So after understanding the logic part, then we will move to the implementation part. And in the implementation part, we are going to implement our logic in Python, C++, Java and JavaScript programming language. Fine guys, and guys, if you want to have a look on the solution which I'm gonna write in this video for Python, C++, Java and JavaScript programming language, I will share the link in the description. You can go through that particular link. You can find all the solution there, right? Fine. Now let's see what this problem says. So let's understand the problem statement. Problem says you are given a m cross n integer array grid. So first of all, you can see guys, the first input is nothing but we can say m cross n matrix, right? 2D array. Let's set here 2D array. Fine. There is a robot initially located at top left corner grid 0 of 0. Let's create a 2D matrix. So here if I have this matrix, right, this is a 2D matrix. So at the top left corner means the nothing but this one, right? So here we can say this is nothing but our robot is standing, right, or located, right? Now the robot tries to move to the bottom left corner, right corner. So now what robot want to move to this particular location, guys, this particular location. So what want I want to be on this location, right? Fine. The robot can only move either down or right at any point of time. Now there is some condition for robot as well. Robot can either move, if robot is standing at here, robot can move to this particular cell or this cell. Robot cannot move diagonally. Robot cannot move up. Robot cannot move left. Robot can either move on right side or down side. Simple thing, right? It makes sense, right? It's only two conditions for robot. Robot either can move to the left, right side or down side. Fine. An obstacle and space are marked as 1 or 0 respectively in the grid. Now, an obstacle means nothing but error. If you know obstacles, that means robot cannot pass from that particular cell. Let's say I have this grid, right? And my robot is standing. Let me just give it a space. If my robot is standing here, right? Robot can move right or left side, bottom side, right? And if I say on this particular space I have obstacle, means there is a rope, something you can see there's a wall, something is there. So what we can do, robot cannot move to this particular direction. So here robot will move now, robot can only move to the down, right? But from here it can move to right or bottom, right? But on that particular place robot cannot move to the left side, right side, right? So it makes sense, right? So whenever robot can see obstacle, robot cannot go through that particular cell, right? Robot will say I will not follow this path, I will follow another path. I hope it making a sense, right? Fine. Now return the number, a path that robot takes cannot include any square, that is obstacle. So that makes sense, right? If robot cannot move to this particular cell, robot cannot go this particular cell, that means this will never come a path, right? So this can only take this path, but this will never come a path, right? Fine, it makes sense, simple thing, right? Now return the number of possible unique paths that robot can take to reach to the bottom right corner. So what is the main goal of this problem? In that, we are standing at the top left corner, we want to reach to the top right corner, right? And we have to find just total number of distinct way, unique path we can reach from top left corner to the top right corner. Simple thing, bottom right corner, right? The test case are generated so that answer will be less than or equal to 2 raised to power 10 raised to power 9. So you don't need to find any modulus of something else. Your answer is already coming in 2 into 10 raised to power 9 in between, in less than or equal to this, right? Fine. Now let's see whether first example and second example, then we'll understand more this particular problem. So in the first example we have this particular grid, right? You can see 0 0 1 0 1 0 0 0 0, right? This one represent this, there is obstacle, right? Fine. So now what we are going to do, we are going to say we are standing at this, we want to reach to this bottom side, right? Fine. What I can do, I can simple move to this direction, you can move right, there's no obstacle, and you can move this as well, right? So okay, now from here our robot can move down. Why? There's obstacle, but it can move only left, right? And our here robot cannot move to the right side because there's obstacle, but it can move down as well, right? Fine. So now here we can only move to the bottom. There's out of bound right side, right? So it's fine. Here also we can move to the right, and here you can see, guys, we here we cannot move to the top because top is also not a direction, right? We can only move right and down. So here we'll move to the right, and we can see that we go to our goal, bottom right corner, and here also we will move to down, bottom right corner. That means only two paths is there, right? Simple thing. Let me just make it a skill here, right? This is the one path, and this is the second path. There are only two paths exist where I can reach from top left to the bottom right corner, right? Fine. And the second example, you can see we are here, our goal is this, we are standing it here, so there's only one path exists, right? Second path has obstacle, so we cannot take that path. So you can see only one path is exist, which is nothing but move to the bottom and go to the right. I hope it makes sense. So this is a simple example, right? And now, guys, I hope you understood. With this example, you may go to logic, right? I know you, if you know a little bit recursion, DP, or something, you can easily we can solve this particular problem, right? But let's see again how we can solve this problem. So I'm gonna write a logic. First of all, we are gonna see with the recursion, then we are gonna see with the memoization, then we are gonna see with the tabulation. Means we are gonna completely do with this DP here, right? So let's see first of all recursion how we can do this. So guys, I'm going to take only first example. So here I can say this is nothing but 0, 0, right? 0, 0 cell, right? 0 row and 0 column. Well, let's say I'm going to start from 0, 0. First of all, in base condition, I can write if 0, 0 have obstacle or the last bottom right corner is have obstacle, means n minus 1, comma n minus 1. This has obstacle. That means you have to directly written what? 0. There is no need to search again, there is no need to traverse over this, because if your starting point has obstacle or if your ending point means bottom right corner have obstacle, then definitely you cannot reach or you cannot start from there, right? I hope it makes sense. Fine. So this base condition we are going to write. Now we are starting from 0, 0, right? Right. So we can say fine. Now, as you know, guys, they have told us what? They have told us that the robot can move to the right or to the bottom side, right? So for each particular node, we will have a two option. The first option is move to the right side, move to the left side, not left side, move to the bottom side, right? So from 0, 0, the right side is going to be means nothing but you have for right side what you are going to do, you are going to increase a column only, right? So you can say I am going to increase a column, so 0, 1. From bottom side I am going to increase a row 1, 0. Fine. Now from 0, 1, I can move to the left or right side, so I can say okay, I can move to the right and left node tab, right and bottom. So for right side I have to increase again a column 0, 2. For bottom I'm going to say increase a row 1, from here as well increase the column 1, 1, increase a row. This is nothing but 2, 2. So fine. Now again, if you will see, this is nothing but 0, 2. We reach to this particular side, 0 row and 2 column here. So here you can see this is also not having obstacle, right? So you can say move to the left, right or bottom. So for right, you can say increase a column, but you can see this is auto bound, right? And in for bottom, you can say 1, 2. For this as well, but here you can see this is 1, 1, and here we have obstacle, so we are not going to proceed here. We are going to say return 0. So it's going to return 0, 1, 1 again return 0, 2, 0 have a not have obstacle. So move to the left, right side first of all, 2, 1 or bottom 3, 0. Now you can see 0, 3 auto bound, return 0, 1, 2 have no also not auto bound, not have obstacle. So we can move to right and bottom. So we can say right side 1, 3 and bottom 2, 2. Same goes for this 2, 1. Right side is going to be nothing but 2, 2. And bottom is going to be 3, 1. And this is auto bound, right? Fine. So you can see guys, this is also auto bound, but this is nothing but our bottom right corner, right? You can see bottom right top because of bottom right corner, which is nothing but 2, 2, right? So we reach to 2, 2. Let me show you here. We reach to 2, 2 here. We reach to 2, 2 here, right? This is auto bound, right? So we can say here this is going to return 1. This is going to return 1. So you can see guys, we got only two path only to reach to 2, 2. There is no more because recursion left. So we can see we are our answer is going to be nothing but 2 only. You can see in the example as well. Let me just go to split up. Our answer is 2 only, right? So that means nothing but they are going to return 1, they are 1. Rest of the thing is going to return 0. This is also going to return 0. This is also going to return 0. This is also going to return 0. And how recursion work, you know, guys, backtracking, right? So this is 0 plus 1 is going to be nothing but here what we can see here is going to get a 1 only, and 1, 0 is also 1, and 1, 0 is also 1, right? So this is going to completely this is going to give us a 1 only path, and here as well 1, 0, 1, 1, 0, 1, 1, 0, 1. So 1 plus 1 is equal to 2. So we are going to have an answer is equal to 2 only, right? So this is the simple equation. Now how we can memorize it? You can see we can memorize on the basis of cell row at I, j, right? Why 0, y 1. This can be repeated in future as well, right? And you can see 1, 1 is repeated 2 times, right? So that means nothing but we can say we can memorize it on the basis of row and column. If we are getting the same row again or same cell again, then we can directly return the value of this, right? I hope it making a sense, right? So this makes simple sense. Yeah, that is the only way we can say simple, guys. We can memorize on the basis of I, j, and you will get your answer done in the optimized manner as well, right? So this is the simple recursion memorization method, and we will solve this particular method in Python programming language, right? And in the C++, Java, and JavaScript, we will use a tabulation. So let's see the tabulation approach as well, right? So this is the one approach we have already seen. Now let's see the tabulation. And this color is not like right. Let's take this particular color. So we have this cell. We are going to take a first example only. We have this, this, this. We are standing over here. Let me just give start. This is end. and there is obstacle, right? So we can say obstacle. Fine. Now what we can do in tabulation approach, we are going to make a matrix, right? Same thing, we are going to make a matrix. So I'm going to say fine. Let me just give it name. I'm going to create my DP matrix, right? So I'm going to say this is my DP matrix. Let's give it a name. All right. So initially all are 0. Why I'm creating a DP of 3, 3? Because I know the my matrix or that particular grid we are given is nothing but having a 3, 3, right? So we have created the same matrix with the default value 0. Now fine. Now what I'm going to do, I'm going to start from the starting position from 0, right? Initially they already told us that we have to check two conditions. If this cell is having a 1 or the last cell is having a 1, directly return 0, right? We don't want to proceed our research, right? We don't want to search how many cells exist, because we know if there is an obstacle, robot cannot start. If there is an obstacle, robot cannot reach to this particular cell, right? So there is no meaning to sense. There is no sense to find a path, because we know we cannot reach to the last code, right? Or we cannot start from the starting position. So why we need to find? It makes sense, right? So we can say if first cell is 0 or the bottom right cell is 0, that right cell is 1, that return 0, right? Fine. Now the second condition which we are going to use is nothing but we are going to say start traversing. We know this is also not 0, 1, this is also not 1, right? Now what we are going to do, we are going to say simply fine. So we are at 0, right? So we are going to say we are standing, robot is standing here, so this is nothing but a 1, right? On here is not, here is start, here we can say in this grid it is 1, right? Fine. So this is going to be a 1, right? Now we can say for this cell, what, how many paths is going to be there? First of all, we are going to check there is obstacle. No, there is no obstacle. So we are going to say fine. So for this, the total number path is going to be what? So for this, I can say dp of I comma j. Let's say this is any I of j. The total number path is going to be what? Is going to be sum of this side, and sum of this side. Why? Because from this cell also we can reach to this one. From this cell also we can reach to this one. There is no way we can reach to this cell from any other side. We can either we can reach to from this side, or we can reach to this side, right? Because robot can only move to down, or we can say right side, right? So I hope it making sense. So if you can reach to this cell on from this side or this side, right? So we can say for dp of I comma j is going to be nothing but I minus 1 of j plus I j minus 1, right? For any cell, your total number path is going to be I minus 1 of j plus I j minus 1. So let's go through this particular one, and let's try to find out how we are going to get 2, right? So initially we were starting our position, we are saying that over standing over there, so we kept 1, and rest is 1, nothing but we can say 0, 0, right? Fine. So we was here, now we reach to this particular cell, right? So for this cell, so we know this is not obstacle, so we are going to say fine. So for this cell, what is the total number of path is going to be? So left side is 1 only, right? So we can say 1 only, because bottom is out of bound, right? For this cell, it can only take the left side and top side. So left and top is nothing but we can say top is out of bound, left is 1 only, so 1. Fine. Now we come to this cell, we can say this can only take the top side. Why? Because left is out of bound. Fine. Here is the obstacle, guys. So we can say this is obstacle, so this is not going to take a top side as well as the left side. This is going to remain 0 only, right? Fine. So we come to this cell now. Here this cell, we can say this is not obstacle, so take a bottom, top side and left side. Left side is 0, but top side has 1, so 0 plus 1 is 1 only, right? Fine. Now we come to this cell. So here this cell, we can say top side is 1, left side is out of bound, so take only 1 only. Now we come to this cell, top side is 0, right? You can see top side is 0 and left side is 1, so 0 plus 1 is 1. Now we come to this cell, so you can see top side is 1, left side is 1, so 1 plus 1 is nothing but 2. So you can see at the end, the last matrix is nothing but 2 only, right? So nothing but what we are doing, we are skipping that particular cell which have obstacle. Otherwise we are taking top side and the left side sum, right? Sum of top and left. And if something is out of bound, we are making it, we are not taking that particular cell side, right? So as you can see from this cell, top was out of bound, so we are not taking, we are just going with the left side. And here you can see here left side is out of bound, so we can see we are not taking, but we are taking a top side and we are moving ahead. Simple regression, just dp of I comma j. Just remember this relation is going to be dp of I minus 1 top side, we can say left side, plus dp of I j minus 1 top side. If any of this out I minus j is not equal to is not greater than or equal to 0, that means we are not taking it, it is out of bound. If j minus j is also greater than or equal to 0, then only we are taking it, otherwise we are not taking it because it is out of bound, right? So it's simple thing, guys, and we are doing all this thing if our matrix of I and j is not equal to 1. If it is equal to 1, that means this is obstacle, right? So then we will not do this, otherwise we will do this. At the end we are going to return dp of n minus 1 and m minus 1. Why? Because this is the last bottom right side where we want to reach, where the robot want to reach, and this will tell how many distinct or unique way or unique path we have to reach to this particular cell. So here you can see we got 2, because there is only 2 unique paths exist. The first path is this one, the second path is this one, right? Now let's move to the implementation part. Let's see how we can implement this, right? So guys, I'm first of all in Python, and what I'm going to do, I'm going to say define. In Python, we are going to use a recursion approach, right? Memoization approach. And so, and here we're going to say row and column. And first of all, base condition, I hope you remember. If first of all, let's calculate the length, n and m. N is going to be row, m is going to be column, right? So row is nothing but obstacle. Let's give it a name is simple. We can say grid, right? So length of grid and length of grid of 0. Fine. Now we are going to say fine if our grid of 0 comma 0 is 1, or we can see you simple this grid of n minus 1 m minus 1 is 1, means nothing but if top left or bottom right is 1, so we can simply say what, we can simply say return 0 type. We don't want to proceed for the searching. Fine. If it is not the case, then go is this function, and in this function what I'm going to do, I'm going to say fine if I is equal to n minus 1 and j is equal to m minus 1, that means nothing but we can say return 1. We reach to the bottom right corner, right? If we didn't reach to that, first of all check if grid of I and j is equal to 1. If it is 1, that means this is an obstacle. So what we are going to do, we are going to simply set it in 0, right? And one more thing, if our I is greater, we can say greater than or equal to n, or j is greater than or equal to n, then also return 0. Why? Because we reach out of bound. I will making a sense, right? But if it is not the case, then move to the left, move to the right side and the bottom side. So we can say return solve of I plus 1 comma j, move to the right bottom side, plus solve I comma j plus 1, j plus 1 because move to the right side. So fine. After that, we can call this function solve 0 comma 0, and whatever this is going to say, return that what question. Let's run this code, and this will work, right? But it will give a TL error for this part. So we got a grid, right? Fine. Let's see. So we got what? We got grid of 0 is equal to 1. So here also we have used grid, right? Let's see now. And here again I have used a grid. So I don't know why I use a jet, not grid. Fine guys, now let's see. Okay, we got something issues with this return 0. Let's see now. I don't know why in this just basic code I'm doing this much error. Fine, but it will work, right? Return again return. Let's see now. Hopefully it should work. Again a grid. I think I should make a change with this one, right? It's easy to type grid or grid. I don't know. And here it again will give an error solve. Today is a very bad day. Simply I am saying that today is Saturday and I don't know what I am doing. I have done a lot of stuff, but yeah, finally it will work. Let's see. You can see guys, both the test case passed. Finally in just 5 line of code we have seen a lot of error, but hopefully it is work, right? But if we try to submit this code, then definitely we will not gonna submit it. Why? Just the reason is guys, it will give a TLE because there could be a lot of possible ways, right? On each particular node we have a two way, right? So if there is going to be 10, so 2 raised to power n, there is going to be n possible nodes, so n 2 raised to power n possible way is going to be open there, right? So what we can do instead of that, we can use a memoization here, right? And for memoization, either we can use a map, or either we can use a met array, or either we can simply use in Python cache. As we know that memoization is going to happen on the basis of this I comma j, right? So cache, what it will do is will basically store this particular parameter in their cache, and you will see if we are calling the same function with the same parameter I and j, so it will directly return that value, right? So let's see whether we can find a node now. And you can see guys, it successfully got submitted, right? I'm really sorry guys, I have wasted a lot of time here by just doing a simple typo mistake, but yeah, it's fine. Now let's move to the C++. So what I'm going to do, I'm going to say initially here take a n, which is going to be nothing but, let's give it a name, not grid this time. This time we'll take a matrix, right? Matrix dot size, and we can say m is equal to matrix of 0 dot size. So we have done this part. We have taken a matrix of size and matrix of 0 of size, means nothing but n and m, row and column. Now we are going to check if matrix 0, and we can say nothing but, we can say 0 is nothing but equal to 1, or matrix of n minus 1, m minus 1 is equal to 1. That means top left or bottom right is 1. That means directly we have to return 0. Now we are going to use a tabulation approach here. So for tabulation, we are going to create a grade vector of int. The name I'm going to give grade and size and rows and m column. By default value will have 0, and the first cell will gonna have a value 1. So we can say why I use a grid, I use a TP, right? TP is gonna be nothing but 0 comma 1, right? So first cell I have put a 1. Now once this is done, then I'm going to use the recursion for int I 0 I less than n I plus plus tabulation approach j is equal to int, let me write int j is equal to 0 j less than m and j plus plus, right? So this is nothing but our grid or matrix TP, right? Now we are going to say, as you can see, we are going to take for each cell. Let me just first of all show you if TP of I and j is going to be nothing but what? Is going to be never TP of I minus 1 of j. This is nothing but top, and this is going to be left side, right? So TP of I and j minus 1. So this is going to be simple, this relation. But there could be some condition. What is condition? First condition is if our matrix I and j is equal to 1, that means this is obstacle. So what we need to do, we need to say simply continue. Fine. And if I minus j, if I minus 1 is greater than equal to 0, then only you have to add this cell. But otherwise it is out of bound, right? So what we can say TP of I and j, right, is going to be method plus equal to TP of I minus 1 and j, right? Fine. And if j minus 1 is greater than equal to 0, then only you have to add this cell because it could be out of bound as well, right? So TP of I comma j plus equal to TP of I and j minus 1. Fine. Now we can comment this line because we have added this both line. Now at the end, what we can do, we can simply say return TP of I, not I, n minus 1 and j minus 1. Now let's see whether we have done something wrong in this one or not. Let's see. Alright, so you can see both the test case passed. So let's submit this code, guys. I hope it will also gonna submit. So it's taking a time, but you can see it is successfully got submitted. Now let's move to the next programming language, which is what we can say Java. And in the Java, what we are gonna do, we are gonna simply say first of all find a row and column. So again, I'm gonna give a name matrix dot length, and int m is gonna be a matrix of 0 dot length. We are gonna say for first of all check if matrix of 0 and 0, you can see 0 is equal to 1, or matrix of n minus 1 m minus 1 is equal to 1, then what you have to return? You have to return the actual 0. We don't want to search it, right? But if it is not the case, then you have to get a one TP array. TP is going to be nothing but new int what is the row and column? Row is going to be n, column is going to be m. Fine. Now we are going to say TP of 0 comma 0 is going to be 1, right? And we are going to use a tabulation for int I 0 I less than n I plus plus, for j is equal to 0 j less than m j plus plus. We are going to say first of all if TP not TP, if matrix of I and j, right, if this is equal to 1, that means this is obstacle. So you can simply continue. We don't want to take this particular path. But if it's not the case, so we want to take it, and we'll say if I is minus 1 is greater than equal to 0, then add left side dp of I of j is going to be nothing plus equal to dp of I minus 1 and j. Same thing if j minus 1 is greater than equal to 0, so add a top side, so dp of I j plus equal to dp of I and j minus 1, right? Fine. At the end, we can simply say return dp of n minus 1 and j minus m minus 1. Fine. Now let's see whether this working fine or no. And do we have something wrong here? Let's see that. So yeah, we have it wrong. That is nothing but it's saying that unknown identifier expected, right? So we can do this thing. This is giving an error, right? Let's see now. You can see both the test is passed. So let's try to submit this code. And you can see, guys, it's successfully got accepted as well. So we have done with Java. Now let's move to the last programming language, which is for JavaScript. And today is the error day for me. I don't know why I'm getting errors. Fine. So here I'm going to say give a name. Let's give it a name obstacle grid only, right? So in Java, what we are going to do, we are going to say first of all find. We are going to say find length. So that n is going to be what obstacle grid dot length, and m is going to be what obstacle grid dot of 0, and here we can say length, right? It's fine. Now we are going to find if obstacle grid of 0 comma 0 is 1, or we can simply last one thing is 1, right? Fine. Obstacle grid of n minus 1 and n minus 1 is 1. So this is what bottom right. Then we have to directly return 0. Fine. Now we are going to say fine create a array for dp array. So we can suppose dp is going to be a new array of how much size. So how much size is going to be there? New array of n size, right? Then we are going to find and then fill 0. So what we are going to do, we are going to say fill 0. Fine, we have fill 0. Then we are going to use a map, and in the map we are going to say find. So in map we are going to call a function. We are going to find here we can say new array of m size fill 0. So this is a simple. We have created a 2D array of n cross m size. The name is dp, and by default value is going to have 0. Right. Now we're going to traverse our loop for in let I0 I less than n I plus plus, or in let j is equal to 0 j less than m j plus plus, and here we can say if our matrix of not matrix we have obstacle grid only. Obstacle grid of I and j is equal to 1, that means this is an obstacle, we don't want to take it, so continue here. But if it is not equal to 1, that means this is not an obstacle, we can take this path. So we are going to find the total number of paths for this particular grid is this particular cell is going to be 1 at the left side and top side. So we can add only left side when I minus j minus 1 is greater than or equal to 0, right? Then only we can add left side. So we can say dp of I comma j plus equal to dp of I and j minus 1. So I did a left side. We can add a top side if I minus 1 is greater than equal to 0. dp of ij plus equal to dp of I minus 1 and j, right? So we have added a bottom top side as well. At the end, what we going to do, we are going to say return dp of n minus 1 and n minus 1. So at the end, we will return this one, last cell, because robot want to reach to the last cell. Now let's see whether it's okay, fine or no. So we got a wrong error, which is nothing but 0. We got only 0, right? So why we are getting a 0? Let's see that part. So we haven't defined a right. We haven't said dp of 0 and 0 is going to be 1, right? Because robot is standing there. So we have to say it is going to be 1. Fine, now let's see. So you can see guys, the test case passed, selected to submit this code, and hopefully it will also gonna submit. And you can see guys, it successfully got submitted. So we have done the implementation with Python, C++, Java, and JavaScript programming language. We have done the memorization approach or recursion approach with the Python, and tabulation approach with the C++, Java, and JavaScript. If you have any kind of doubt in the implementation part, problem understanding part, logic part, you can write in the comment section. I'm always there to help you. And if you learn something new in this video, don't forget to hit the like button and subscribe my channel. Meet you in the next video.